Clean record. All right. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on Twitch from scratch. No engine, no libraries, no nothing. Just so we can learn basically everything that is involved in the complete sort of software stack of a game all the way down to the hardware, which I think is actually really important and is becoming a little bit more of a lost art these days. So this project's kind of an attempt to bring that back, to basically have everything there from start to finish, so anyone who wants to really study how games work through the entire pipeline, through the entire code base, have the opportunity to do so. And I think it's really great too, just in general, for everyone to kind of be aware of this sort of stuff. I know it certainly makes it much easier for me to do any kind of work that I'm doing on games, whether it happens to be using libraries or happens to be using engines or not, because you can always go in there and fix stuff. You can debug so much more effectively. You can know when something is suspicious, just when you have sort of that kind of full background. So that's what we're doing here, and we have basically finished sort of our prototyping layer. We made a Win32 layer the past couple weeks so that we can basically do all of our own stuff right on top of Windows without having to use any libraries or anything. And it's pretty basic at this point. It does basic sound output and basic bitmap output, and also it does basic input from user devices like keyboards and gamepads, and that's really everything that we need to get a game up and running. So that's exactly what we're going to start doing here. But I felt like we had done a bunch of the hard work of like picking through Windows and like dealing with all of its APIs to do stuff, and really we were just doing that in order to get sound output, bitmap output, and input into the thing. And so what I thought would be nice to do tonight is to do something fun with the Windows API to kind of show like, okay, when you're down there and you're doing crazy stuff, you can actually do some cool things if you've done all of this yourself. And so what I wanted to show is kind of like an example of something pretty cool you can do, and it's going to be an example of sort of something very useful to a game developer. So if you are following along at home here on day 21, if you have purchased the source code using this handy dandy pre-order button here on handmadehero.org, you will get a link in your email that should have allowed you to basically, there's a link that comes when you pre-order the game, and that will always allow you to download the source code. So save that link, go there, and there should be a day 20 zip file inside the source code zip. If you unzip that one, that is the source code we're starting with. So look for day 20, because every day we start with the previous day's source code. So if you unzip that into a directory, you will have exactly the same source code that I am starting with now, so you can follow along at home, which I know a lot of people like to do. So let's go ahead in there, and we have some stuff. We have a few issues that I have in my notebook that I want to address from previous days, but right now I'm just going to go ahead and do this. We'll get to them in the Q&A. So I'm going to go ahead and jump right into like new stuff, sort of the fun stuff that I want to do. So, all right. So basically, one of the things that people often ask me, in fact, they asked me this multiple times on the sort of about Handmade Hero. They basically say like, are you going to implement a scripting language? This is asked. This has been asked many times. Or more specifically, I suppose, are you going to use a scripting language? And the answer is no, of course, we're not going to use a scripting language. But the question of whether or not we were going to build a scripting language, well, that would still be making something from scratch. So we could decide to build our own scripting language if we want to. But we have to ask ourselves the question, is building a scripting language really all that great of an idea, right? And in order to know whether it's a great idea or not, you have to kind of stop and ask yourself, what do you think you're going to use this scripting language for? And is it going to provide more benefits to you versus the downsides that a scripting language has? And of course, scripting languages have a lot of downsides that maybe people don't realize right away, one of which is performance problems. Because remember, if you implement a scripting language, you are also on the hook for ensuring that that scripting language is performant, which may mean that you have to use just-in-time compilation or all these other sorts of things in order, if a significant amount of your game is written in the scripting language, you're on the hook for that performance. And that's something you have to be aware of, right? It's not like C, where you know how to optimize it and you've already got tools to profile it and all these, and an optimizing compiler there to back you up. It's not like that when you're using a scripting language, you're on your own, right? And similarly with scripting languages, you have to ask yourself, what are you going to do about debugging? Do you have a debugger for the scripting language? Are you going to write one yourself? Are you going to use some third-party one? And will that integrate properly with the debugger for the platform that you're using? Or are you going to have to constantly ping-pong back and forth between debuggers? There's all sorts of things that could go wrong. And so when you're talking about implementing a scripting language, there's a huge number of costs that go with it. And so you have to be very aware of those costs. That doesn't necessarily mean that you shouldn't do it. But it does mean you have to think very hard about whether or not it's a good decision. For Handmade Hero, since we're doing everything from scratch, I think it's kind of a no-brainer that it would be a bad decision, because we're certainly not going to want to take the time to write a debugger for the scripting language and an optimizer for the scripting language, a compiler from the scripting language, blah, 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 blah. All the things we would have to do a really good job of using the scripting language in a game. We're not going to do those things because that would take a huge amount of time out of learning the stuff we want to learn, which is more about how to write the game code. And so given that that's the case, I would then say, well, okay, what are the reasons why people might want a scripting language? Like, what is a scripting language good for? Why or do they even think they need it? And can we just go ahead and get those benefits without having to do all of the work, right? So I think one of the primary benefits of a scripting language is that people perceive it to be easier to write things in a scripting language. I don't really know necessarily where that comes from so much, because I think it's actually pretty easy to write things in C if you make the API to it correct. So I don't think we're going to have too much trouble writing our game code in C. I think we're probably going to be fine with that. But one of the other things that people often point to in scripting languages that's a benefit is the fact that we can do things like edit the scripting language while the game is running. Now, this is a pretty big bonus in a lot of cases, because if you can edit the scripting language while the game is running, you can tune variables live on the fly. You don't have to try to, exit, recompile, go back into the game, that sort of thing. And you can also do stuff like, well, if you're trying to debug the behavior of a boss monster, you can just go in there, when you get to the boss monster and see that it's not working, you can just right there pop up the script, start editing it, see what the boss monster does, and change it and all that stuff. And it saves you from having to make a whole bunch of scaffolding to allow you to exit the game, change some boss monster code, jump back into the game, jump straight to the boss monster, actually deal with the stuff there, look, see how it went, go, oh, okay, it didn't work, jump back out, blah, blah, blah. So there's kind of a lot of stuff there where it's like that ability to just use, to edit the code right in the middle of the game is pretty valuable, actually. That's a pretty big thing. And so there is something you can do there, right? You can, inside Dev Studio, right? If I open up Dev Studio, there's a thing called Edit and Continue. Right, which allows you to edit stuff inside Dev Studio. You can set a breakpoint, you can edit some stuff, and you can have it recompile, and that works for some very limited cases. Like, unfortunately, a lot of the time, edit and continue doesn't really work. Like, if you're writing tons of new functions, and if you're actually trying to really write new code, edit and continue doesn't work. It's usually for small changes is the only thing that it's really reliable for. Otherwise, it mostly just breaks. So edit and continue isn't really a good solution, but it's sort of like what we would want, right? What we'd like to be able to do is just kind of go like, all right, the game's running and we have the C code. We want to just be able to edit the C code and have the game just keep on running, right? So the question is, well, could we basically implement our own version of edit and continue, right? Like, is there some way that we could go ahead and do that where we actually don't have to worry, we basically don't have to care about Visual C++ and whether it can do whatever it's supposed to be doing with its compilation step? Could we actually make it so that we have what amounts to our own sort of relatively foolproof edit and continue? And so what I'm going to do tonight is I'm basically going to try to implement that. I'm going to try to implement a way where we can basically have our game running, change the code live, and not have to restart the game to see the results, and just basically let us kind of go from there. And we'll see how far we can get towards that goal, basically. And I think that's kind of fun, so I said tonight's kind of time to do something fun. Rather than spending all our time doing stuff just to get Windows sort of as a conduit working, let's see if we can actually use Windows to help us now to make something pretty cool. So the first thing that I want to do is go, all right, well, what I know about the way that I've set up the game, because I think I've architected it pretty well, is basically I've got this sort of platform independent part here, right? That's going to hold all of the game code. It's going to hold that stuff that I want to be able to edit on the fly. And then I've got a Win32 portion, which is separate. So the first thing that I'm going to want to do is I'm going to say, well, could I just split those two things apart so that we basically have one part that's the platform code that's compiled separately, and one part that is the platform non-zip code that's compiled separately. And then maybe, just merge them together. And, can I do that in some way that doesn't force us to unload, to kill the executable? And you've already basically seen the answer to this question is yes, right? Because you've already seen that we have a thing here, which is basically the load library. I don't know if you remember when we were talking about this kind of a while back. We have the ability to load code out of a library already dynamically, right? We can basically pass a file name that's one of these DLL things, right? That's something that Windows has implemented. We can load that in. We can call getProc address on it, right? And getProc address will give us a pointer to a function that's in there, and then we can just call the function, right? So if we want to do that, we could just do that with our own code. So there's really no reason why I couldn't, instead of compiling this monolithically as one translation unit, I just compile it as two separate translation units, one for the platform code, one for the platform independent code, right? And that platform independent piece of code, I then just load as if it's a DLL. I call into it to do whatever it is I need it to do. And then when I want to refresh it, if I feel like it needs to be reloaded, I can just close it. I can just free library, which is the corresponding call to load library. I can just free that library and reload the new freshly compiled code, and I don't have to kill my executable, right? I mean, it should just work. So the reason that this is simple is because, as you know, we're basically passing in the game memory as a chunk. Now, I've said a couple of times that there's a lot of good reasons to do this. Well, this is a big one of them. Since we're passing in all of the game memory, the game itself is not, the actual game code is never actually doing anything with memory. So if we just hold on to that game memory which we've allocated, we pass it to the DLL when it needs to run, we can unload that DLL and we still have all the memory. So if we then reload another DLL that's a new version of the game code, we can just call into that and pass it the same exact memory that the previous DLL was using, and poof, it'll just go ahead and keep running in there. Now there's a couple caveats of times when it doesn't allow you to do that because of depending on what you change in the C++ code. But for now, that's a pretty easy way to envision a very simple way to make this work. So what I'm going to do here is I'm just going to change our build.bat a very, very tiny amount, right? Basically, instead of compiling this 64-bit line, instead of compiling it this way, I'm actually going to compile two different things. I'm going to compile the handmade.cpp. I'm going to compile that, and I'm going to compile the Win32 handmade.cpp, exactly like that. So basically what happens here is inside this, where we have this sort of stuff here, right, I'm effectively going to start to bifurcate these two code paths, right? I'm going to go ahead and take into handmadehero.h. I'm going to go ahead and pull the things that we actually had pound-defined out here, right? I'm going to pull those into here, like this. So that now I've basically got, oops, I should keep that at the top. So that now that I've kind of got those out there, this guy is still going to look at handmade.h, right? Like this. This guy's still going to have to look at that. It's going to need to see a couple of these things, right? But now it's no longer going to include this handmade.cpp anymore. That's not going to happen. So instead, handmade.cpp is only going to happen inside actual handmade.cpp. So it's going to be compiled separately. We're not going to like pound include the CPP file into Win32 handmade, right? Does that make sense? So then all I need to do in my build.bat, and there's a couple other things we're going to have to do here, but basically all I have to do in my handmade here.bat is figure out, my build.bat I should say, is I have to figure out what to pass to this CL thing to build one of these DLLs, one of those DLLs that we were loading before. Basically, the compiler has the ability to build DLLs as well as link with them and so on, like we were doing where we're linking with import libraries and doing stuff like that. It has the ability to build DLLs itself, so what I really want to do is just make it so that I can build that DLL as well. And so what I have to do there is, I believe, I think it's a pretty straightforward switch, actually. I believe it's just a DLL switch to the linker. It's been a long time since I passed it, but I'm pretty sure there's almost nothing to it. It's like, yeah, it's just that /DLL. I believe that's pretty much almost the entirety of all we're going to have to do. So /DLL there, I think is all we're going to have to do. And I don't think we're really going to have to do anything else. We don't actually even need most of those other libs there, because really, in fact, we don't really need any of this stuff. None of these common linker flags are actually relevant to us. I think all we actually need is the /DLL. So let's go ahead and take a look at what that does first, just so I can see what's going on here. All right, these guys are no longer internal. Obviously, these are actual linkage calls. We'll have to deal with that in a second here. Let's see here. So we got to get rid of that because they're actually going to be exported. This is the first time we'll ever have an exported function. Let's take a look. We've got, those are not, yes, right. These are the calls. These are our calls back into it. Let's see here. Go platform read entire file. So these are no longer internal either. Those are going to be like that. And there we go. All right. So now I think besides having our unresolved externals, I think we're in pretty good shape here. Let's take a look at our errors in Win32 Handmade as well, because we were expecting linker errors that we're going to deal with those in a second. I'll explain how to deal with those in a second, but I just want to take a look at these. Let's see here. We've got, right, these are no longer internal. These are called externally. Although that's not really true. Well, we'll see in a second what we do with those. Those are probably premature. All right. So basically, all I did was I just split the code into two compilation units. And as you can see, there's basically places where they called each other: game update and render and game get sound samples, and then the debug read free file memory, write entire file, and read entire file. These are basically the places where our two halves of our code called each other. And so as you can see, now that we're compiling them separately, we just get a bunch of linker errors that tell us, you know, I can't resolve this stuff anymore. You're calling stuff that doesn't exist in the translation unit. I don't know where to find it, and that's an error. So what we have to do is figure out ways to resolve these. Now, the two where the platform layer calls the game, I just said how we can do that. That's really straightforward for us to resolve. We're going to treat it just like we treated xinput, where we're going to load library and do that kind of stuff. You can see here where we basically have sort of these get proc addresses, this sort of stuff. That's all we really need to do. So really all we need to do here is basically do something where we go Win32 load game code or something like this. And all we're going to do with that is we're just going to do that load library, and we'll call this handmade.dll for now. We can obviously play with that a little bit later. Handmade code, or we can just call this game code, or game code DLL. If that actually works, then we will try to do get proc addresses on it, and those get proc address calls will give us the pointers to those exported functions that we wanted. So basically we're in here. You can see we've got game update and render and game get sound samples. All I'm going to do now is do the exact same trick we did for xinput. It's going to be literally exactly the same. It's this exact stuff right here. Nothing else to it. So all I'm going to do is basically say there is a game update and render, and that takes a name, and it is exactly this function prototype that we had here before. So I'm just going to go ahead and make that like this. Then I will make a type def for it, just like I did before, and this will be called game update and render, and then I will make a stub for it, just like I did before. So this will be game update and render stub, and of course that doesn't need to actually return anything. So that's it. That's really all I need to do there, and we don't actually even need a global variable for it, I don't think. We might do something slightly different than that. So I'm gonna delete those. Those do not need to be there. So this is the entirety of what we needed to do there, and we'll get rid of that like that. Okay. So we're going to do that, and then the other thing that we're going to do is we're going to do the same thing for get sound samples. So get sound samples, again, will be a game get sound samples, and this will take a name. And then we're just going to use this exact same function prototype that we were using before for game get sound samples, only now it'll do this. And then I will do a type def of it. Did I remember to remove the semicolon there? No, I did not. Doesn't really matter, but I want to get rid of it anyway. Just to be cleaner, you can have more than one semicolon at the end of the line. It doesn't seem that anyone really cares a lot of the time, but just, you know, just to keep it a little cleaner. So this is game get sound samples, right? And then I'm going to do a game get sound samples, get sound samples stub, like that. So that's really about it. Then what I would like to do, because I don't see any reason why not, is I would like to then say, well, we're going to do, so there's a couple different ways that I could have done this. In fact, you know what? Maybe I'll do this slightly, even a little bit differently, instead of having stubs for these, since I don't actually really need this. Well, yeah, no, it's a little. It's a tough call. It really is. But you know what? I think I'm gonna do one more. I think I'm just gonna go one more, and I'm gonna do game get functions. Let's say we call it game get functions. And basically, game get functions is just gonna be something that basically returns these functions. Oh, well, do I need? You know what? No, I don't. I'm only gonna have two. I'm conflicted. You can hear it in my voice. You know it's true. But I'm not. I was gonna try a different way, and I just wasn't sure. I can't quite tell exactly which one I want. But I'm gonna stick with the one that I was originally doing. So we're gonna do it that way. And that means that inside here, I'm also going to go ahead and say that game get sound samples is actually going to be one of these now, right? So that's that. So that'll automatically define that for us. And game update and render is also going to be one of those. So there we go, like that. And we may have a little bit of funkiness that we have to do there as well that I'll tell you about in a second, but yeah. So now, hopefully, we can still compile, and we can, so that's good. And now, inside here, when I do the load game code, remember I'm still including handmade.h just so I can see these defined types here. Basically what I want to be able to do now is I want to be able to actually get proc address these things here. So I'm going to try and load game get sound samples. I want to load that. And that is a game get sound samples pointer, like that. And that's going to load from our game code DLL, right? So I want to do that. And I'm going to make a little struct here, which is win32 game code. And it's going to have pointers to both of these things. It's going to have pointers to this, that, and pointer to this. So that's get sound samples. And this is game. Well, actually, I don't need the word game anymore. That's get sound samples. And this is update and render. And basically what I'm going to do here is just say that there's a win32 game code struct. It comes back from this. So we have win32 game code. That's the result. And basically what happens is that, right, we will initialize to the stub functions equals the stub there and result. There's a stub there. So basically, get sound samples. We will start off pointing just to stub functions, so things that don't do anything. Then, assuming we can actually load it, we will go ahead and do it this way, so we can get our functions in here. So get sound samples. We'll go there, and game update and render. We'll go there, update and render, like that, and there we go. Okay, so that's pretty good. And then I will return that result back. Okay, so now what should be able to happen, just to start things off, to get us sort of in striking distance of what we want to do, at least in the platform layer stuff, I'm just going to do this sort of at the outset. The first thing I'm going to do is just do this. Now we're going to have to move this later because we want to load things on the fly, but for now what I'm going to do is just do this. And then from then on, basically, I should have two errors here. Yeah, I can just do game code or just game update and render, and then the get sound samples, right, can be game.getSoundSamples. And let's see here. So there we go. So now our Win32 platform layer compiles properly. And basically what it's doing now is instead of actually calling functions that are in its own executable so that the linker resolves them, now what it does is it leaves those function calls, it makes those function calls go through pointers. And those pointers we are loading inside this game code function. So basically, anytime we want to, we could always just reload them, right? We could go ahead and full on reload them. And I also want to set us up for success here to the extent possible by basically saying that the DLL itself will go up here. And so that way we'll track basically when we load it so that we can basically free it later to load a new one, right? So I just want to track that instead of it having it be entirely local to this thing. So there we go. Now we've got that stuff. And what I want to do here, again, is also check to make sure that we actually got these and that they're not bogus. So what I can do is basically have something in here which is like, is valid or something like this. And basically, I can make is valid be equal to these two guys. Oh, in fact, you know what? There's another thing I can do here, which will be cool. So we'll check to make sure we got both things. And if we didn't get both things, then it's invalid. But what I can also do there is move this down here, right? I can say if it's not valid, then set them to the stub function so no one fails. So that's kind of nice and clean. That'll work pretty well. But now we at least can return to whether or not we actually think we got the functions that we wanted to get. So that seems like it should work okay for now. And that will load that handmade.dll. But now we have to deal with the reverse process, right? How are we going to deal with that? How are we going to deal with that? Because we can't get proc address back on our executable. Or maybe we could. We could load the executable in the DLL, load a handle to that, and reverse call into it, right? We could do that. Could do all sorts of fun things. But if you think about it, really there's no need to do that. That would just be a waste of everyone's time, because if you think about it, when we pass in our structure here, we pass in all these things when we call game update and render. Everybody is getting the game memory struct, for example. We could just decide that inside the game memory struct, we also pass the pointers to the debug services, right? We can just flat out pass those, right? Because these things here don't actually have to be function calls. They can just be pointers to function calls, right? So we can do the exact same thing in the reverse, only instead of having to get proc address them, we just pass them, because we already have a pointer to the game code. So when we call into it, we'll just pass it, right? It's totally simple. It's trivial. There's no reason not to do it. So let's go ahead and do it. So the debug services will just be done the exact same way. Basically, we have debug platform read entire file, and that's it for that. We will type def that this way, right? We just have to go ahead and, oh wait, that's not right. There we go, debug platform read entire file, and that will just take this guy here, okay? And then the same is true for the rest of these guys. Debug platform free file memory. Oops, that's no good. That goes in here. So that'll basically be the same thing again. Name, type def, debug platform free file memory, like that. And this should be name as well. Get those out of there. Okay, the type defs are good. And the last one, same thing. So basically, instead of actually ever defining the functions in here, this is write entire file. Instead of actually doing that, we're just going to not do that. We're just going to define what types they are, and assume later that someone will pass pointers of them to the game, right? So write entire file, there it is. So now we have defined the types for those pointers and a macro that defines something of that type, so that we can use that inside the platform layer. And basically all we need to do now is just pass these to the game. So I'm going to stick them in game memory for now. I'm just going to say inside game memory, you actually also get basically pointers to all these things. Debug. Oh wait, that type. Those are named wrong. Those are named wrong. That is a typo. Go back up here. This should be debug platform free file memory and debug platform write entire file, like that. Okay, so basically all we need to do is just actually pass pointers to each of these things, like this, right? That's it. And so this will be debug platform read entire file, debug platform free file memory, and debug platform write entire file. So we have those now, and sort of what we've done here is basically created our own little vtable, if you think about it. It's sort of almost like making our own little dispatch, only instead of it having to be all C++ and weird, we actually can see it and do whatever we want with it. So now, when we pass game memory, we should just be able to call our stuff directly out of that. What did I do? I did something wrong here. Undeclared identifier debug plat. Oops, that's no good. That's no good. Got to pass the name. There we go. And then in these, so anywhere where we were calling those now, we can just call them straight off of our memory, right? Just like that, and that's it. So basically, I think that is basically all we need to do here. I've got to move that up above there because this actually calls that. That should be it for that. All right. So now all we have to do is actually initialize those in our memory call. So these should actually be, these guys here, should actually be using this macro, because that way if the macro changes, these will be correct. So we've got free file memory, and I'll rearrange the order here. I like things to always be in the same order everywhere. I don't know why, but I just like everything to be in the same order. It's some kind of OCD tendency. So anyway, we'll go ahead and do that. So there we go. Debug platform free file memory. Write entire file will now be defined with the macro. So again, this is just making it so that I don't have the same parameter list in tons of different places, because that just makes for more maintenance work for me, which I don't want to do. So there we go. And now if I build this, we should be good to go. Of course, we have never actually, when we created our game memory struct, we haven't actually set the pointers in it, so they'll all be pointing to 0, which means we'd crash immediately when we tried to call them. So we'd know, but I'd rather just not have to go through that crash to see that. So what I'm going to do instead is just go ahead and initialize them to what we would then go and do after we saw the crash. So let's just skip that whole crash process if no one has any objections. Basically, I'm just going to initialize those pointers so that when the game gets the memory struct, it has each thing initialized properly. So that's it. That's basically the end of it, right? I don't think there's really anything else to do. So now we're actually compiling correctly, but let's take a look to see if we actually got in our build directory what we wanted, right? Because I don't actually know if we did or not. So it doesn't look like we did, because I passed that DLL switch, but you notice we're still building an exe here. And I don't want it to build an exe. That's not what it's supposed to do. So I still am, I'm not passing the correct things. So let's double check that I'm not doing something wrong. So let's see here. Maybe that because we're specifying other things that it's a problem. I'm not entirely sure. Let's take a look. Let's take a look. Because all we really need to do now is make sure that that's actually getting followed. Is this something that you pass to there? Entry point must be defined. That doesn't help us. And if it's link, yeah, what's going on there? Why are we not getting the DLL that we asked for? Because we asked for a DLL and we're not getting one. So basically all we have to do is decrypt the magical switches and then we will figure that out. So it's still producing an exe. What are my common compiler flags? Let's see. Nothing suspicious there. There's an output of the map file, which should probably be specified separately, but that's really not going to do it. That's a separate thing entirely. That's just we will need those to output two different things is all. But yeah, I don't see, it looks like we're outputting everything as you would expect. So I'm not sure why it's disobeying my DLL call. I do not actually know why it is disobeying that call. So there, now it's producing the map properly, but it's still producing an exe. So let's double check. Let's see here. Module definition statement, the base and DLL options together are equivalent to the library. A DLL usually contains exports. Yes, I know, we're going to do that in a second, but what I want to know is why won't you build a DLL for me? I just want you to I just want to see. I just want to visually see that you're outputting it. CL flags to make a DLL. So please tell me, what does Stack Overflow say? Here's your big chance to redeem yourself, Stack Overflow. Be correct about something. Let's take a look. What is this? This doesn't look useful. This doesn't look useful at all, actually. No. Come on, people. How hard could this be? I mean, seriously, there should just be like a thing that's like, here's how you build a DLL, right? I mean, how hard is this? Normally what I do is I go open up one of my existing projects that builds a DLL and I look at what it does. But of course, I'm trying to go through the steps I would have to go through if I didn't have anything. So I can't actually do that. So why, Mr. Finicky, do you not seem to want to do that? It says right here, the DLL option builds a DLL as the main output file. I am passing it, but it doesn't actually seem to do anything. Now, if it's not followed by /link, if I just do that, it says entry point must be defined. So maybe what's happening, I'm going to guess, I'm going to hope, this is my hope, that passing it after the link thing actually makes it not work, and this makes it work. Because we don't specify a DLL main, which is something we would actually probably need to do. So let's hope that this is the correct switch, and we'll go add the DLL main and hope that that was actually doing it properly. So I'm gonna hope that that's true, and then it's just like if you put it after the /link, it doesn't work because it doesn't. All right. So basically what we need to do here is inside handmade.cpp, right? We still have the problem of, we basically still have the problem that we need to make a Win32 version. So we have our Win32 handmade sort of library thing, but we also have our Win32 handmade game or something like that. So we've basically got two Win32 things happening, if that makes sense. So basically what I want to do, because, how should I say this? Executables have the same thing, DLLs have the same thing as executables. That's a good way to say it. Windows will still call us even if we're loaded as a DLL, it will still call into us for no real reason other than to give us a chance to do startup stuff. So really, we don't actually need Windows to do that, but Windows is going to do that. So even though we're building a chunk of code that we don't actually need it to jump into, I don't know if there's a way to tell it, just don't bother jumping into us. So what we need to do is just put a little stub in there. Now we could do that in one of two ways. In fact, maybe this is an easier way to do it, I don't know. Like we could not do this. We could just stick a stub at the bottom of handmade.cpp, right? You could go in here and do something like this, but it maybe is a little uglier, right? We could do something like say, okay, if it's handmade Win32, right? Then we just stick the stub in here because it isn't actually code that anyone has to read, and it could go below here. I don't know how I feel about that. Like I said, I like to keep the code segregated in multiple files, but we could. And so basically what we would need to do, I'll do it in here, and then we can kind of look at it and decide whether we care about that and whether we want to move it out. Basically, we've got this thing here, which is DLL main, and DLL main basically is essentially the same as WinMain, right? Basically, it's just a thing where this happens. We have to include windows.h to define these things, and then we just go ahead and we have to process this call. Now, I don't actually think there's almost anything that you need to do. I think it's all pretty rote. Let's take a look. Those are community editions. Do we have a... is there... There it is. Using dynamic link libraries, creating a simple dynamic link library. There should be just the bare minimum yeah, of stuff that we would need to do in a dynamic link library. Let's see. This doesn't seem to be... This is not what I want. This is not what I want. I want something that just shows me the minimum set of things to do in a DLL main. Let's see here. Let's see. Here we go. So basically, this is where Windows is going to call us back in our DLL when that DLL gets loaded into memory by another process, which in this case is also going to be our process. So basically, these are the things that it's going to ask us to do. Attach, detach, and so on. It's basically saying, okay, process attach, thread detach, process detach. So it'll call us at this DLL main every time a process or a thread starts using the DLL or stops using the DLL. We don't need to do anything because we're not going to master any resources, right? The whole point of this platform non-specific code is that it doesn't do anything other than respond to calls from the platform layer itself. So really all we should have to do, honestly, is just return true. It looks like there's absolutely nothing that we would have to do here. So I think we can just do that and leave it at that. However, okay. So what's the problem here? If I actually compile this, it says entry point must be defined. I have the DLL main that you asked me for. So why are you complaining? This is the part where I'm not sure if the slash d excuse me, the slash DLL is actually working. Of course, let's take a look here. If I was to go into Win32 Handmade and put a WinMain in here, would that compile? And if it does, yeah, we're sad. So it's still not building a DLL. So Windows, why are you not building a DLL? Just tell me, you know? You don't have to be cagey. Why not? I really don't understand why. Let's see. What is the reason why? I'm not sure. I honestly don't know. I must be forgetting something, and it's going to be just the standard thing where you kind of slap your head and go, ah, and feel stupid at the end of it. But let's see here. Let's see. Surely there's just a simple DLL example or something that I can just see what it is. So we've done this. But this is not. The following example is the source code needed to create a simple DLL. But this doesn't even require, I guess, so is it just that we haven't exported any functions? Is that the problem? Well, I guess we're gonna have to do that anyway, so I'll talk about that and we'll see. We'll see if that's the case. All right, so basically what has to happen in order for a DLL to export entry points, basically, because remember, the compiler is gonna compile this code, it's gonna output a DLL for us, and a DLL is something that's essentially executable code. It's essentially the same as an exe, right? But it has a table in it of places in the code marked by strings. So you can basically say get proc address, like we did before, pass it a string. It will look at the DLL and it's got a string table in there that maps strings to locations in the code so that you can basically do linking at runtime dynamically, which is why it's called a dynamic link library. And what we will have to do in order for this to happen is we will have to actually have some things that are exported. Now, one way to do things that are exported is to put decal spec DLL export in the code. This is just some crazy syntactic stuff that Microsoft's compiler basically uses to tell you that the thing that is being exported, the function that it's tagged on is going to be exported. We can use that, but another thing we can do is we can just specify what the exports are directly. And I don't actually remember exactly how to do those, but they're actually pretty straightforward if I remember correctly. Basically, it's like, yeah, it's this. So you can actually just on the link line, if you don't want to crud up your code with Windows-specific stuff, which we'd like to minimize as much as possible, you can use /export on the link line to basically say that a particular piece of code is going to be /export. Now, there's one caveat to that we'll see in a second. But basically, /export, I don't know where it's got the define for that. Should have it in here somewhere. Let's see, MSVC /export linker switch. There we go. Let's see here. Exports a function. My net is slow, or maybe it's just MSDN that's slow. All right, so basically this, right? So basically what this does is you can basically say, okay, I want to export a particular name. I want to export it, and I can just give the name of the function there. But there's a caveat here that we'll see in a second. Basically, okay, I'll put it in and you can see what I mean. So I'm going to do export entry name here. I'm going to say that I want to export get sound samples because we said we wanted to export that. And I also want to export game update and render, right? So I just want to do those two things, right? Well, okay, guess I got to put them after the link line. Like that. All right. So, yeah, I just don't know. I'm failing tonight. This might be an owl of shame moment because I'm failing just to know what the compiler switches are to do the thing that I actually needed to do. I really need this thing to actually build the DLL for me, but it really doesn't seem to want to. But now that I've got some exports, it seems like it's actually doing it. So maybe the whole time it was really just upset about that. I don't know. But it's still outputting an executable. You can see that it's outputting an executable, which is kind of weird. But anyway, all right. But it's creating a lib. Do you notice that? So it's actually creating an import library as if it was about to build a DLL and even an export too. So very strange. But let's just finish what we were doing and then we'll go try to debug that some more. So anyway, I've got the exports here: game update and render, get sound samples. But there's a rub basically, which is that we have not actually marked up these functions to avoid having them be name mangled. Now, I don't know if you remember the name mangling stuff I showed where C++ mangles the names in order to work with old school C linkers. There's this sort of whole process. I talked about it in detail. Hopefully you guys remember. So if we look at what these functions actually get called, they ain't called game get sound samples and game update and render. Their names are something totally different. So in order to make sure that they don't essentially get mangled in that way, I can put a thing called extern C in front of them, if that makes sense. And what extern C does, and do not ask me where they came up with this particular syntax, it's very different from just about anything else. What extern C does is it says, okay, this function in particular, it needs to be following the old school C convention. Don't mangle the name. right? And so if we take a look at what actually gets output, hopefully it will get output in the map as well, so I can actually show you. .map, let's see, update and render, update and render. Let's see. Ooh, why did I use that? That's not what I meant to use. I used the wrong function there. Date and render. Okay, there we go. So here's the simple demo of this. So before extern-c, game update and render, I'm going to do the build. I'm going to look at the map file, which remember I said is the thing that gets outputted that shows us where all our functions are. And now I look at what the names of these things are. Well, here's the name-mangled version of that, right? It's total crazy town, right? It's like it's not the name at all, okay? And so if I go in now and I add that extern-c, you can see now that it will change it to what I actually wanted, which is just the straight name, game update and render, game get sound samples, right? So that's exactly what I wanted, and that's it. So the only thing we have to do now is try to convince MSVC to output a .dll. Now, I suspect because it actually imported I suspect because of the way that it did this, that we could actually load the executable directly. I feel like it's just naming it exe or something, but hold on a second. We'll actually try that and see. So basically, if I go up here, instead of loading handmade.dll, I load handmade.exe. I just want to see what actually happens. So let's go ahead and step into our code here. When I load the game code, I want to see what happens. Yeah, so it's opening up this, right? It's opening up this guy. And then it goes ahead and asks for game update and render, and it got it, right? So there we go. And hey, look at that. It's actually, well, no, actually, I think it's probably not quite working at that point because we should have seen we're not actually getting the game code running. Let's see there. But it actually got update and render. It got an address back for it, and it got an address back for sound samples as well. So I'm not sure is valid. Oh, right, typo. Not valid, then we overwrite it. So let's take a look now. Yeah, so who knows why? We'll have to figure out why Windows is deciding to create an exe instead of a DLL. We don't know yet. But basically, it doesn't matter for our current purposes. Maybe we'll do it in the Q&A, because I'm sure someone on the stream has already thought of what the problem is. So basically, what we're doing here is now we're actually loading our own code dynamically, right? We're actually loading out of that exe that was produced. We're doing the load ourselves, this handmade.exe, right? So now what we could do if we wanted to, we can make it so that we can just reload that code on demand, essentially, right? So if we want to, we can say, okay, this is Win32 load code. We could also do something like this, Win32 unload game code, right? Which would basically be taking this Win32 game code thing here, and it will take one of these and unload it, just flat out get rid of it, right? So we've got our game code. It's going to take a pointer to the game code, and it's going to go ahead and say, if it's valid, right? Well, actually, I guess it doesn't even need to do that. It's just going to go ahead and do a free library on game code DLL, right? Assuming that game code DLL was actually DLL. There we go. Assuming that it was actually there, it's going to free it, and then regardless of what it's going to do, it'll just go ahead and set this stuff so that basically the game code is no longer considered valid, right? It's not valid anymore, and everything is reset to the stubs. Game code, update and render, game code, set sound samples, that, and so that'll unload our game code, right? So let's see, no object file generated, unload game code unreferenced local function. Okay, well that's fine because we're about to use it. So now, if we really wanted to be absurd, which I don't want to be, but I'm just going to demonstrate the fact that we could be absurd if we wanted to, in theory. We could go ahead and actually just load and unload the game code every time through this loop, right? There's absolutely no reason why we couldn't do that, right? I can go in here and I can say, all right, I'm going to take this game code and I'm going to load and I'm going to unload it every time, right? So there's the load. Oops. Sporadic key class. There's the load. There's the unload. So what I'll do is I'll go into our running thing. At the top of the loop, I'll load the game code in, And after we're done with our game loop, I'll just unload it, right? Which one of the, let's see here, that's while global running, so there we go, and that's the, yeah, samples. So in theory, I think that'll actually work, but it'd probably tank our frame rate, but I think it actually would work. Let's find out. Yeah, so it's gonna ruin things a bit for us, but you know, it appears to work. And you can actually see it if you actually look in here, if we look at our history, you can see us unload and load, unload and load, unload and load all the time, right? So basically what's happening there is it's actually going to load and unload this guy, that stuff that we built in here all the time. Now, what we can do is we can go in here and say, now we actually have a problem, I just realized. We still have a static variable in here, right? That T sign should have gotten moved out to the game state, but it never did. So we need to get rid of all our local persist because there shouldn't have been any more of those, and that's going to cause a problem because those things are in the DLL, so if it gets loaded and unloaded, they're going to reset every time. So we've got a T sign here. Let's go ahead and fix that so that T sign actually gets initialized properly. So in the game state, when we set the tone hertz, we're going to go ahead and set the T sign equal to 0.0f, and now when T sign gets used, we're actually going to use sort of the game state T sign. Right, so let's see here, game state, and all I'm doing there, really very straightforward, right? I had a old static variable, a local persistent variable, and I don't want that because we don't want anything stored in the DLL. We just want everything to come in the standard memory like we planned. And so I'm going to go ahead and do that, and now we just need to pass that game state because presumably this does not take that currently. So here we go, game state, right up in there. So game output sound now has to take the game state, but other than that, everything is good, and let's rerun it. There we go. Good as new, and somehow that is so fast that we actually can do it every frame. I guess because our code is so small, it's a little surprising, but it kind of works, right? Now in theory, and I don't know because we're loading and unloading it so fast, the compiler may not be able to slip in there to actually write the file. In theory, what we should be able to do, if we really want to, right, is while this is running, we should now be able to do some really crazy town stuff, right? We should be able to come in here and say, okay, I don't know, the game's running, but if I wanted to, I could come in here and say that this was actually going to be shifted up 16 instead, right? When I compile that, yeah, so that's the problem, is it can't ever open it for writing. Do you see how that's happening? So I got to do the next step of my process before we can really get to the awesomeness. All right, that's okay because the next step is pretty darn trivial. The next step is pretty darn trivial. So all we have to do now is we're loading and unloading this code every frame, but we're loading and unloading it so fast that the compiler doesn't actually have a chance to write to the file because it's always being opened by ours. So I guess one thing I could do, here's an easier way to do it than what I was going to do. So let's actually try to verify that this works first, and then we'll go back and do it the fancier way, because we're almost out of time, and so maybe the fancier way will have to wait till tomorrow. So where is my load game code? So here's my load game code. So all I'm going to do is I'm going to load the game code before we enter here, right? But then I'm going to take the free code, the unload game code, right? And I'm actually just going to do, at the top of the loop, I'm going to do the unload game code. And then I'm going to do the load game code immediately after, right? And I'm going to actually, I think what I want to do here, well, no, this is fine. So we'll basically just do this, right? So there we go, like that. So all I'm going to do here is I'm going to basically say, you know, I've got a counter, load counter, and that load counter is going to be like every 60 frames or something like that, right? So every 2 seconds. Maybe we'll make it a little bit more, right? Like that. And what I'm going to do here is basically say, if the load counter is greater than 120, then we'll reset the load counter so that we just do it every few times through the loop, if that makes sense. That's all we're going to do. So we will say every time through the loop we increment the load counter. This will give us 120 frames at 30 frames a second is like 4 seconds. That should give the compiler some time to open the file. So that's all I did, is I just said, all right, let's only unload and load it that frequently, if that makes sense. So off we go. Let's see now if we can actually get the file to open at some point. So let's see here. Can we do it? Can we do it? Can we do it? No, we can't. Well, I wonder if I'm doing something wrong in terms of freeing the library, because that could also be the case. Free library. We are doing the free library, although this should actually do. I should actually set this so that it's clear what's happening here. For some reason, that is, oh, well, duh. I don't know why I thought that was going to make it any better. Now that I think about it, that's just dumb. Because basically, yeah, basically I still have to do one more step of the process, because this will still only leave it unlocked in between there. Just because I'm not reloading it again, obviously the DLL will be locked while it's being used. So I got to do one more step of the process, right? What I got to do is I got to make it so that I'm not locking the thing that the compiler is outputting to, right? So the way that I'm going to do that is I'm just going to, when I do the reload, I'm just going to copy that file, right? I'm just going to use the copy file call, which is a Windows call, right? Copy file. And the copy file function just basically takes two things and does the copy, right? It just takes an existing file and a new file, and it copies from the existing to the new one. That's it. And you can pass it whether you want it to fail if the new file exists or not. So if you want to always create a new one, which we don't. So all I'm going to do is basically like there's something called, let's say, handmade temp.dll, and I'm going to copy handmade.exe to that handmade temp, right? That's all I'm going to do. Nothing particularly weird there. I'm going to do that copy, right? And the copy is going to allow me to lock a file that is not the file that the compiler is outputting to, right? Pretty straightforward. So I know that'll work because now I'm not locking that file anymore. I'm locking a different file, and I know that I will do the copy when I have it unlocked. So let's take a look at this here. Oops, that's not good. Looks like my copy did not work particularly well. Did that actually work? Where's my copy file? Oh, because we're running in the data directory as well, aren't we? Okay, so we need to do one more thing, which is a little janky. Okay, but we can get around that for the time being. All right, so basically the problem here, though, is this stuff only works. This is only without a path. This is only going to work if this stuff is in the current directory. So what I need to do temporarily is set the current directory to that, because until we do the full thing, which I guess we'll have to again wait till tomorrow to do, we don't know where we're looking for stuff. We don't know where those DLLs are going to be. So we don't really want handmade. We don't really want to hard code this path in there. So what I'm going to do is I'm going to actually just run it in the build directory where everything is, and that should actually work, right? And so now you can see if I look in here, it actually did that. It did that copy that I wanted to do. And it should be doing that copy every so often, right? Because remember, I put a timer on there. Well, not really a timer. It's a frame counter on there so that it'll periodically do it. So now when I go in here, in theory, I should be able to actually write to the file, but I don't actually know. Let's see. Error writing to program database, handmade.pdb. Oh, okay. So we do have one more problem, which is that the debugger itself is locking our PDB file as well, which is definitely not what we wanted it to do. Oh, debugger. Well, all right. So we can still make this happen in the short term here. We can run our game outside of the debugger, and we can do this, I suppose. Let's see here. There we go. So there you go. This is now actually doing what we wanted it to do, which is basically we can edit the code and have it update while we're running, right? And we don't actually have to stop the executable. And again, the state is all actually there as well, right? We could get to the boss fight, change the code, and see it update in real time and without having to do anything, right? So it's sort of as good as having a scripting language in some sense. It basically allows us, if we want to edit all the code. And we can do all sorts of weird stuff here, right? We could decide that this was, some other thing, and that would just be, I don't know, whatever. You can see whenever it updates, we don't even know what it is, but you can play with the patterns here and get pretty immediate feedback. Now, the feedback's not quite instant because we're waiting 4 seconds between reloads. But what we'll see, we're out of time tonight, what we'll see tomorrow when we do all the rest of the stuff that has to back this up, because we only just got it in with the wire tonight, What we'll see tomorrow when we do the rest of the backs up is how to make that basically instantaneous, so that as soon as we hit recompile, it'll reload. So there you go. That was just something, again, like I thought we deserved to do something fun because we had done so much sort of just wrote stuff with the Win32 API where we kind of just had to play by its rules and do what it wanted us to do so that we could get access to the stuff that we wanted to. I thought maybe it'd be fun to do something cool with the Win32 API that lets us do something interesting. And this is not specific to Win32. You can do these same sorts of tricks on other platforms as well, because almost every platform supports dynamic linking. So anyway, this is kind of awesome. I like this sort of thing because it just makes it feel a lot cooler when you can code to just do that. And then it's like once you change the thing, I don't know, it just makes it cool. So you can see now we're only clearing like half the screen, right, or whatever, et cetera, et cetera. But we've got a lot. This gets way cooler. So we'll do a much cooler version of this as well sometime soon. Let's also do, I don't know, let's play with the size of the gradient maybe. It's just fun to watch it go sometimes, right? There's one that's sort of wider, right, and so on. So anyway, that's pretty cool. I hope you enjoyed that little trick. We're not done with it. It's not nearly as cool as it's gonna be tomorrow, but we only barely got in there. And also, we do not know, I still don't know why it's outputting an exe. I gotta go, I'll go look at my other stuff and find out why I don't know. Because it still seems to want to do an exe export, and I do not know why. All right. So anyway, there we go. We've basically taken, I mean, that was not very much work, right? All we did it extremely, all the work that people put into scripting languages, and like at the end of the day, there's a lot of stuff you could just do and see if you just tried, right? And so this is an example of how to do that. And now you can reload all your code, not just your scripting language code, at runtime, right? So we can reload all the engine code too if we want to, which is going to be pretty awesome. Now there's a problem, of course, which is if the game crashes, what do you do? But that's the thing we're going to take care of tomorrow. So anyway, so for tonight, just to recap what we did, as we enter the Q&A here, please make sure your questions include senioratory in them, so I'll see them, and try to keep them on what we did today or past. But I'm just going to do a quick recap here because I went pretty fast through everything there. Basically what we did is we took our build.bat file. We decided to build two things instead of one thing. We split the game code into one basically executable chunk and the platform code into another executable chunk, right? We then have the platform executable chunk load, and whenever it wants to, it will reload the game executable chunk. It then calls Windows to ask it to give it the address of functions in that chunk, in the chunk that it loaded. It says where's the sound samples function and the update and render function, because that's the two functions that I need to call. It gets those back from Windows, it calls them, and when it calls them, it passes in a struct, in addition to the structs we already defined, like the off-screen buffer and that sort of stuff. In addition to those, we also pass in any functions that we need it to call us back at, right? So any calls that go back to the platform layer, which are only debug calls at the moment, but if we had any that were actually real calls, we could pass those, right? Those get passed in so that the game has pointers back to where the functions are in the main executable as well. That's all we did. And then we just put in a simple frame counter so that every 120 frames it tries to reload the game code. That's all we did in the code proper at this time. So there you go. Pretty simple, really straightforward. If you architect the code correctly in the first place, like we did, this is trivial. And hopefully you saw that it was trivial. In fact, most of the work we have to do is figuring out which darn switch to pass to CL to get it to output the DLL. That was like most of the time. But yeah, but there you go. So I'll go to the questions now. Okay. So a bunch of people say they think maybe /LD will tell it to output a DLL, not an executable. So let's try that and hope that they're right, because yeah, we don't have to produce a DLL. As you saw, an executable works fine, but it just seems nicer to do a DLL because that's, I don't know why. That's what people do. So let's try it, LD. Incremental link. Oh, so one of the things we also, I forgot to do this. One of the things we also should do on our common linker frags is turn off the incremental linker. Because since we build everything from scratch every time, that's just wasting everyone's time. Is it incremental? No? Okay. So let's see. I'm going to go in here to our build directory. I'm going to delete handmade star. All right, so that's gone. And then I am going to rebuild. Let's see what we get here. Yay! Okay, thank you, stream. That is what we needed. We just needed to specify some extra sauce here to just tell it, I guess the /LD switch. This /DLL switch, I guess, tells the linker to output a DLL, but the /LD switch tells the compiler to do a DLL, and this must mark it so that it gets an exe name instead of a DLL. I don't actually know the interaction of these switches. I'm not sure. It might be that we don't need this one anymore as well. Like once you pass this, it may automatically imply that. I'm not sure. Let's take a look. Yeah, so it looks like we can just pass that. So basically, I guess it's just if you happen to be calling CL, which is itself going to summon the linker, you do /LD, I guess, is how that works. I'm not sure. But thank you, stream, for that's really all we needed to get that going. So what we can do now is do what we wanted to do here, which is instead of loading handmade.exe, we can load handmade.dll. Okay, and I'm going to put the to-dos in here as well. So Casey to-do, need to get the proper path here, right? And to-do automatic determination of when updates are necessary. Okay, just snuggle those in there for tomorrow. Okay. Use a key press to unload and key press to load. No, so we're going to do something better than a key press to load and unload tomorrow. So we should be fine with that. So we have small code right now. How does dynamic linking and compiling to an exe work with huge games that are gigs? Well, first of all, the reason most huge games are huge is because they are not written right. I know that's kind of a strong thing to say, but basically, this game will never get huge. We will never have a 20 gigabyte executable. That's just not going to happen. So we really don't have to worry about it. The reason that sort of thing happens is because of bad programming decisions, basically. And sometimes those bad programming decisions aren't bad in the sense that they were made because there's 1,000 programmers on the project and there's no way to actually get everyone to do the right thing. So it was just better to have the thing be 20 gigs and whatever. And so I'm not trying to point the finger at people and say you were stupid or anything. You may well have been smart and it was the only thing that you could do. But when you are architecting things properly, you will never, ever, no matter how complex the game is, you will never have a 20 gigabyte executable. That's just not going to happen. So you're pretty much safe. Let's see here. For people suggesting find first change notification, don't spoiler tomorrow's stream. I'm not going to tell you what we're using. We're going to use some stuff tomorrow, but that's for tomorrow. No spoilers. Let's see here. I always have problems with loops and how they work. Have you, in all your years of coding, learned an easy way to help with loops? That I do not totally understand, CI12. I mean, a loop is just very simple. A loop basically is this. Right? A loop is basically some point in your code, and you do some code, and then when you get to the end of it, you go back to the point in the code, right? And basically, the only thing that a loop is a way of conveniently writing, like a while loop, right? Where I have while, something is true, do some stuff, right? Basically, a while loop, all of these just get turned into this form. This is just basically if something is true, go to top, else don't, right? So basically, this is a loop. The condition goes in here, right? the stuff you do goes in here. All these are, and all of C loops are, is basically the stuff that has to get done happens, right? And in fact, in this case, we would skip the first one. So a while loop checks at first. So if something is true, it does the stuff, right? Then it goes back to the top. And if something isn't true, it just doesn't, right? So really, it's just, you can imagine it just executing line by line. You can turn any loop into just an if statement and a goto, really, right? There's really nothing to it. So I don't know, if you have a more specific question, I could try to answer it. But loops, you don't have to think of them as something special. Goto, like jump, is the only thing that actually exists. Goto is the only thing that actually exists at the CPU. Loops are purely syntactic sugar that high-level languages put on top of a goto. That is all they are. So yeah. So yeah, let's take a look here. Do you recommend playing around with creating DLL files, or is it mainly used in specific cases? No, I recommend playing around with them all the time. Yeah, being able to dynamically load code is a great idea. So play around with them, see what you can do with them. I mean, you saw how easy it is. All you have to do is say, here's an entry point, I need it exported, and then you can get proc address it, and off you go. So yeah, see what you can do with it. I mean, go to town. That's what I would say. Let's see. Can someone now create a dummy handmade.dll and use it to intercept the game update and render function to get a pointer to game memory and change stuff? Is security something you will cover in a later stream? This is by Ambiguous Panda. So I don't know why that would be relevant. So one of the important things, so security is one of those things where I don't feel like people really understand it usually. They tend to think that something is more or less secure based on a bunch of stuff that isn't actually relevant to its security. So if you think about the threat model that you're talking about, basically I've got a handmade.exe and I've got a handmade.dll. And the only threat model that I've introduced now that didn't exist previously would be if for some reason someone had write privileges to handmade.dll but didn't have write privileges to handmade.exe. Since they were both installed by the same user at the same time who installed the game, in the same directory, I'm not exactly sure why you would ever think it was less secure to load exe out of 2 files, executable code out of 2 files, than 1. It just really doesn't make any sense, right? Because whoever overwrote handmade.dll could have just overwrote handmade.exe, right? There's no reason for them to attack handmade.dll because it doesn't have any weaker security than handmade.exe had. All virus checkers understand that there's code in DLL and exe, so there isn't such a thing as a place where it's like checking one or the other. So basically, yeah, there's really no security hole there. At least not one that I can think of. So. Also, I think security for games is silly. Like, that should just be built in the OS. The fact that the games have to even think about security is ridiculous, because games should run in a sandbox. They're not an application that interconnects. So, like, the fact you should be able to ship as many security holes as you want in a game, because games should always run a sandbox. It's Windows' entire fault that that isn't true. That was just a colossal bollocksing up, as they say. Let's see here. Let's see. I'm going to post this again because I'm sure mine got buried. We have a tiny application right now. So with code that takes minutes to compile, how do we do what we just did? Okay, so I'm going to say this again. I already answered part of that question, but I'm going to answer it again because you asked it slightly differently this time. You asked about taking minutes to compile. If your code ever takes minutes to compile, you've done it wrong. Code should take less than 10 seconds to compile, period. If your code takes more than 10 seconds to compile, you need to stop and figure out why you have written code that way, because that is a bad way to write code, period. And I know there's a lot of people who will disagree with that statement, but they're wrong. Like, I have never encountered something so complicated that it could not compile in less than 10 seconds. So that's really all I can say. I really don't care what it is. Like, it's just, compilers are extraordinarily fast and machines are extraordinarily fast now. And the reason that things take 10 minutes to compile is because people decided to use all kinds of weird template metaprogramming nonsense and stuff that slows the compiler down tremendously. And if you go that route, then you basically have sacrificed all of the benefits that you could have had. And it's just a really bad programming decision. So don't make that decision, never make that decision, and you won't ever have to worry about it. If you do make that decision, all bets are off, and I really can't help you, right? You're in a situation that you've sort of created, and then you will have to do all sorts of things. Like, now you have to implement an entire scripting language and a debugger and an optimizer for the scripting language because you made the poor decision to write code that takes multiple minutes to compile, right? So yeah, what can you do? Now, what I will say is verify that you really are in that position. Can you break your huge amount of code up into multiple DLLs and only reload the ones that changed, right? You know, can you make, if you've got 20 gigabytes of code, can you break that into 200 DLLs and then you only rebuild one DLL and it gets reloaded, right? I mean, there's an option for you potentially. But there's a lot of headaches that go around along with doing something like that. So again, I don't know. So the right decision, in my opinion, is if your code takes longer than 10 seconds to compile, you've done something wrong. Assume that that is true and build your project from there. Would you be able to load the DLL yourself using read file and implement get proc address as well, assuming there's an easy way to make the memory executable like mmap? Yes, you totally can do that. The reason I'm not doing that is because we would like the debugger to understand the code. So what you have to understand is that a debugger runs by looking at the executable that it is debugging and loading corresponding debug info for that executable. When a dynamic link library is loaded, that is a new set of code that is brought in, and the debug information for that code is not present in the debug info for the main executable. So it has to go and find the debug information for that DLL. Now, the way that it does this is because loading the DLL through Windows' standard hooks, right? Load library, free library. The debugger sees those happen, and it knows to go get the debug info when it sees those happen for the DLLs that it sees loading. If we implement the load ourselves, then we get into a situation where the debugger doesn't know we've loaded that code. So it can't load the debug information, and we can't step through the code that we've loaded, right? You could go ahead and write a symbol server that the debugger connected to and implement your own symbol server, which made up for this shortcoming or stuff like this potentially, which then faked the symbols for the executable to look like they were whatever the symbols were for the loaded code in some back channel. Like, you could do stuff to patch that hole, but it's a real long road if you decide to go that route. So basically the reason that we're using Windows to load this, and the reason that we'll use like other platforms as well when we implement like this on Linux, we'll do the same thing in their way. The reason that you do that is specifically because we want the debugger to understand that we loaded that code and to support us, which it can do if we go through the standard channel. Let us see. Is this technique still possible without using the passing of a large memory block between the DLL and the exe? Well, so I believe the answer should generally be yes. Let me state it this way. As long as the DLL code always gets its memory from the main executable, you will be fine. Now, there's multiple ways that this can happen. One way that it could happen would be to do it the way that I'm doing it right now with those debug calls, where when the DLL gets loaded, it basically gets handed some pointers, and then you call those pointers when you want more memory. Because that way, all the memory is still allocated in the executable, and there's no issues with what happens when the DLL gets unloaded. But by default, that is already sort of what happens in Windows. Because what happens is when the DLL gets loaded, if you use, well, it's not really true. If you're using static linking, I don't know what happens if you just call new, like, or malloc directly from the DLL. I think when you unload it, it'll get freed if it was a statically linked C runtime library in the DLL. Now what you can do is you can change to using a dynamic C runtime library, which means that both the executable and the DLL that you load will share a DLL that is the C runtime library, so they both call into that. But in order to do that, you would have to go onto the build line and you'd have to change this -MT to a -MD or whatever it is. I don't remember. So the short answer is yes, it certainly can work without the monolithic block, but the answer is no, you can't just do it willy-nilly. You have to actually think about where that memory is coming from and make sure that it's coming from a place that won't get purged when the DLL gets unloaded. So you can definitely make it work, but just you have to be aware that it's not free. It does take a little bit of planning, but it still works. Okay. What's next? Does the DLL prevent the compiler from inlining? It prevents the compiler from inlining across the DLL boundary, but as you've noticed, we don't need that to happen, right? We have, like, basically our entire game runs inside this function, right? The entire game is going to be in here. So you call game update and render, and everything that happens in the game is called off here. So all of the inlining that will have to happen in the game happens inside the DLL. We never need to inline across that boundary. So we don't have to worry about that. But no, if for some reason you wanted to have lots of functions in the DLL that were small and were called from the platform layer, and you were counting on inlining to make that fast, that is a problem, and that will not work. But, don't do that. How are we going to implement DLLs on Linux Mac? They basically have the same thing. So they basically have shared libraries as well. They're just called different things, but they're the same. Let's see. Are there VODs for this series? I just stumbled upon it and really want to catch up. Yes, handmadehero.org. If you go to handmadehero.org, you'll have everything that you need. Basically, news and forums, you click on that, and then episode guide will have a bunch of stuff for you that you need. So that is what you want. Let's see here. I'm looking for a new question. That is on topic. Are you ever going to write the platform layers for other platforms on the stream in the far future? Yes. At the moment, if you just want a platform layer to use, you can go to, so at handmadehero.org, if you click on that news and forums thing again, there's a coding resources page, and people have already ported it to both SDL and macOS native. So if you want to just run it on another platform, that's actually pretty trivial because people already did the hard work for you. If you want to watch me port it, that won't happen for quite some time, because basically porting work is just straightforward Grimble work of take the things we did in Win32 and do them in Linux. There's nothing, it's literally as uninteresting as it gets. So now that we have one platform layer working, I'm not going to spend any more time on platform layers until we go to ship things. But if you just want to get it running right now, you can go access those resources. Is the process roughly the same for doing the Linux equivalent with shared libraries? Having seen your Windows version, would a couple hours of Googling and GCC Clang documentation digging be likely to get me there, or should I be looking for something specific? Yeah, I think so. I don't know if David Gao is planning to do so. If you go again to coding resources, David Gao has done this awesome thing called Handmade Penguin. That if you go look on here, it's got all sorts of stuff that you want to know if you're doing a Linux version of this. In fact, it's probably I'm going to guess, and I don't know, but I'm going to guess that this is a better resource than looking at how I will port to Linux, because I'm less knowledgeable about Linux than he is, I suspect. So if he decides to do the DLL loading, you may be able to just wait for him to do it for you, because he may already understand that stuff really well. If not, then yes, I do think that it shouldn't take too long to implement what I just did, because you're just looking for three things. How to export functions from something in a way so that you could basically call the compiler and say, make a dynamic library with these functions exported. Then you just need load library and get proc address. Well, and free library, right? So you basically just have those things to do. If you can find those, that's all you need, right? Tomorrow we'll do some other fancier stuff, and so you may need a couple other things, but if you just want the basics. The Internet FTW says, your pound-defined typedef magic kind of bugs me in that it hides the argument's return type away from the implementation. How much of a win is having the signature in one place? The answer is it depends how many times it happens. So for these, it's probably no big deal. I would say just, if you don't like it, don't do it. The person who's asking the question is asking about these sorts of things that I do to make it so that you never have to change what the parameters are in multiple places for a callback. And yeah, you don't have to do that. If you'd rather not do it, then you don't have to. But there are certain cases where I would strongly advise that you do it, and those are places where you have lots of the same type of call. So for example, if you're making like an entity dispatch and you've got 300 entity types in your system, you really want to use this macro, because if you decide to change the parameters that go to an entity dispatch, you really don't want to go change it 300 times or more, depending on the circumstance. Let's see. How does Windows manage memory in a DLL? Is there a DLL process space? Where are variables made with static stored? How is heap memory managed that is allocated from a DLL? So the answer is I don't remember some of the specifics of that. Basically what happens is, do we have some MS Paint going on here? Yeah. So basically what happens, let's take a 32-bit executable because it's a little simpler to conceptualize. 64-bit is such a much bigger address space. So basically, here's 2 gigabytes of memory, and here's 2 gigabytes of memory here, totaling 4 gigabytes of memory, which for 32 bits of address space is all the address space there is, right? 4 gigabytes is the maximum addressable memory for 32 bits pointers, right? So typically what happens in Windows is you basically have the upper 2 gig. So this is the 2 gig with the high bit set. The high 2 gig is for the OS, and the low 2 gig is for you, right? That's how that works. So as far as I know, what happens when you load a DLL is it just flat out picks a place in here and slams that DLL code right on in there. And basically what it does is it uses a memory mapped file to basically map the file. So if this is the disk, right? If here's the disk, right? You've got your exe is on disk somewhere, right? There's the exe. And here's the DLL is on disk somewhere, who knows where, right? Basically what happens is, well, I shouldn't probably have drawn that quite so soon. Basically what happens, right, is when you start up, your exe is mapped into here somewhere, right? And I'm not trying to say where, I'm not trying to say that it's low, I'm just saying somewhere in your address space. Your exe's file gets mapped in, and then your DLL's file gets mapped in when you load it, right? And that is how the code gets mapped in. Now, when you allocate memory, basically there's stuff in here, there's different ways of allocating memory, right? If a DLL were to call virtual alloc, I don't know whether that counts towards the exe charge or the DLL charge. So So this is why I say I don't remember the specifics well enough. For an exe, if you call virtual alloc like we are, it basically takes some range of your executable and reserves it for use as memory, and you get back a pointer to it. So now the exe is pointing to it. When you leave, when you call virtual free, you can free it, or when your exe dies, obviously that reservation goes away, and all of the information Windows stored about that page goes away. But with the DLL, I don't know if it remembers virtual allocs from DLLs or not. My assumption is that it doesn't, but I could be wrong about that. My assumption is that you could virtual alloc from a DLL. It would alloc in here in your memory space, and that it would just stay. And when you unload the DLL, it would still be there, and the exe could use it. But I don't know if that's true. The reason that I think that's true, so I'll tell you why I think that's true, but you will have to go and verify it yourself, basically. So here's virtual alloc, right? This is what it looks like. And virtual alloc takes an address. It says this is where I want the memory to be. It can be 0 if you just want Windows to pick an address. Here's how big I want it. Here's the type of allocation I want, and here's the memory protection for it, right? Well, nowhere in that code did it have a module handle, right? So when you call this, Windows doesn't actually know who's calling it other than the information about the thread itself that called it, right? It has some way of determining which thread called it, but that's about it. So because that occurs, let's say we go ahead and do a get proc address. So we load this DLL, and there's a procedure in here. We do a get proc address, and that procedure calls virtual alloc. We do a get proc address in the exe. We now have a pointer into this code, right? It's just a pointer. It's just like any other function pointer. When we dispatch into that from the exe, and then it calls virtual alloc, I don't see how Windows would even know that the virtual alloc call was coming from the DLL. Does that make sense? So basically, my assumption is that, like I said, you have to be aware, like I was answering the person before who was saying what happens if you don't pass memory from the executable DLL. You have to be aware that there's a difference between code in the DLL and code in the exe. You have to be aware of it. But it doesn't mean that you have to, it doesn't mean that you can't just do all the things that you want to do. So here's the part that I don't know. There's things called heaps that we aren't using right now, okay? And that kind of looks like herpes. So let's try and draw that again so that it actually looks like heaps. There we go. Heaps are a different thing entirely. Heaps are not virtual alloc calls. Heaps are basically things that have called virtual alloc in some way and are now portioning out that virtual alloc for you as you ask for stuff. So they're more like a traditional memory allocator. What I don't know is if there's a heap created for the DLL that by default calls in the DLL that are static C runtime library allocation calls linked into it at link time, when the DLL is linked. Not dynamic link time, but statically linked in when the DLL is produced. If there is a heap that is normally used that goes with the DLL and that will be freed by Windows when the DLL is unloaded. I suspect that there is, and I suspect that you would get into trouble if you were relying on that. So for example, if you call new, right, and the function new inside this DLL, when it was called, gets compiled to calling an address which uses a heap that is the heap from the DLL in some way. I don't know, right? It uses a static variable that is the heap pointer that got allocated in DLL main or God knows what, right? Hopefully you can follow me why this is not ridiculous what I'm saying. Then it could very well be that that gets purged on exit. So I guess what I would say is there's a lot of things that could be going on here. If you wanted to do stuff other than what I showed you, you should learn this stuff well, and then you should be able to do it. But as a rule of thumb, I would say that if you're only calling virtual alloc, I suspect it would never matter whether you called it from the exe or the DLL, because I don't think Windows knows which one you're doing. If you use new or malloc, on the other hand, those are not operating system calls. Those are calls that call into the CRT. And so the same diagram again, right? Basically, you have to imagine there's a C runtime component of this, right? So here's my exe, and let's say that both the C runtime library, both my exe and my DLL were statically linked with the C runtime library, not dynamically linked, right? Then I look like this. The DLL code has a C runtime library in it, and the exe has a C runtime library in it. Included in this is a static, let's say, a static pointer to a heap that gets initialized at startup. So there's a static heap. If there's a static heap, then that static heap could very well be used by all the calls to malloc that happen in this DLL. Because remember, the call to malloc exists now. There's code for malloc in both of these. And both of them can use a different static. There's a static heap here as well, right? So depending on which compilation unit you're in, you have resolved your calls to malloc to be calling into different pieces of code at runtime. And all these calls to malloc may use this heap, and all these calls to malloc may use this heap, which means two things. One, when this DLL gets unloaded, all the heap goes away that it ever alloced, gone, poof, goodbye, right? But the other thing it means is you better be darn sure that you never pass a pointer that you malloced in the DLL over to the CRT where it then would call free. Because now you're freeing out of a heap that's not the heap you allocated out of. And the same goes vice versa. Don't pass in a malloc here that's going to get freed on this guy's heap, because now you've got a heap mismatch. So the solution that a lot of people use to fix that problem, which I believe is actually a problem. Like I said, I don't remember a lot of this stuff because I don't use any of it anymore. But point being, you know, it's a thing. Basically what ends up happening is you've got an exe here, right? You've got your DLL, which is here. They then have a CRT DLL, so they link dynamically with the C runtime library. Now, both of these guys call into malloc, right? And now you're always using the same heap because the static heap pointer is the same for everybody. So that is one benefit to using, if you're doing crazy stuff like this, which I say crazy, but it's how most people do it. I think it's crazy. But if you were doing crazy stuff like that, that is one reason to use a shared, a dynamic link library for the DLL, because then everyone can just malloc and free memory using standard new and delete or malloc and free, and it just works because they're all sharing the same code for the C runtime library. Okay, so we're basically done here. We're out of time, so let me just double check to see what we've got. Let's see. Let's see here. Let's see here. Enemy mouse, doesn't Windows know by the instruction pointers leading up to the virtual alloc call? No, I mean, it would have to walk the stack, right? In order to know who it was. Because you're not passing really anything that would identify them, I don't think. So it could walk the stack and try to figure out. But, you know, or look at the return value address, I guess, and then you see which one that's in. But, you know, that's work that I don't think it does. Maybe it does, I'm not sure. But we'll see. Again, I don't do any of that stuff because I don't want to rely on operating system behavior that I don't have to. So it's one of the reasons I don't know that answer offhand is because I just don't do that. Because it can only lead to portability problems in some sense if you start relying on stuff like that, I think. So Gareth Lewin is saying that allocating across boundaries, there's a different reason for it, but I'm not sure. He doesn't actually posted what it is, so I'm not sure what the answer is, what he wanted me to say. So I don't know if there is a way he could. Of course, there's a delay, so now he doesn't know that I'm asking him to post what he wants to say, but let's see. So the Internet FTW says from SGN, the system maintains a per process reference count for each DLL. Yes, it does. When the reference count becomes 0, the DLL is unloaded from the virtual address space of the process. Yes, it does. The DLL uses the stack of the calling thread and the virtual address space of the calling process. Yes. The DLL allocates memory from the virtual address space of the calling process. Yes. But that's what I all just said, right? So that sounds like MSDN is just saying what I said. Is there something that... So I don't know, if someone could tell me what they think is incorrect, because I just want to make sure before we end the stream that if there is something incorrect that I could correct it or point people to the correct version of it. But that sounds exactly correct. So I got nothing. So Gareth Lewin, you have a few more seconds here to tell me what it is you think is incorrect. Otherwise, it will have to wait, I suppose, till discussion on the forums if someone thinks there is something incorrect about that explanation. So I will go ahead and say that now. So if we are basically at the end of the stream, but I'm going to wait a little bit just to let the questions catch up there in case someone wants to type in what they think was wrong about that explanation. Basically, if you go to handmadehero.org, and obviously you can pre-order the source on here if you'd like to. If you'd like to follow along at home, you can get the source code every night. I push the source code every night so you can re-download it and see where we were at. If you'd like to follow along at home, it makes it a lot easier. But you can also click on news and forums, and that will get you a little resource site here. It has the schedule for the week typically posted on there. It has an episode guide that you can use to catch up if you're or to re-reference older things. It has a coding resource page which has ports and stuff like that you can go to do, as well as other good informational materials. And finally, there's a code discussion button here, which is where you can post stuff like if you think an explanation was incorrect or you just weren't sure about something, you can post on here and other people and me read it and try to answer those questions to try and help out people who are trying to learn. So that's a good place to go to follow up. So let's see here. Okay. Let's see. So, all right, Gareth Lewin says the mistake is that using msvcrt.dll won't solve the cross-boundary allocation issue. So if you could post a reference to why it doesn't, that would be helpful, because it definitely does in practice, because I have worked on projects in the past which rely on that specific thing, if that makes sense. While the DLL is loaded into the same address space as the application, its own statics are unique. So I don't believe that's actually true. I believe that basically the way that the DLL gets mapped in is statics aren't all the same, if that makes sense. They can be defined as shared or not shared. And maybe, I don't actually know exactly how that's implemented under the hood, but I'm pretty sure msvcrt.dll actually does the right thing there and will uses the same heap for each instance of the DLL that's loaded. At least that was the way that it used to work. I'm like 99% sure about that. So yeah, but all right. So if that's the only objection you had, I'm pretty sure that's not actually true. So we can pick that up on the forums now that I know what the thing is, because that's a pretty small minor thing. So let's go ahead and pick that up on the forums, and we can see which one is correct. But other than that, we are now over time by 15 minutes. So I apologize for the slightly long stream, but I just wanted to make sure that was on there. Thank you everyone for joining us. I hope you enjoyed this little sort of fun dive into how to make C be editable at runtime. Tomorrow we're going to do the super cool thing of making it super easy to edit at runtime, getting rid of sort of some of the hacky things we did just to get it working today. And so after that, we should be in a point where we can just literally leave the code up and running the whole time if we wanted to. I don't know if we should or not, but we could from now on for the most part, except for certain circumstances where we'll have to kind of do some reloading. But we'll do some other cool stuff tomorrow, much like we did today. I hope you enjoyed it, and I will see you tomorrow at 8 p.m. Pacific Standard Time, when we will continue doing some fun Win32 stuff. All right, thanks everyone for joining me, and I will see you tomorrow.